This is Astronomy Daily Live, and it is 2 hours UTC on the 25th of June, 2018. So, hey, everybody, what's up? What's up? Hope everybody's doing well out there in the rest of the universe. Everything is okay here. Nothing, nothing too exciting going on here. Had another nice restful day. Just taking it easy. Not really working on anything too seriously, too intensely at this point. Just playing around with things. Uh, yeah, not doing not doing much. Reading some papers. Just sort of the normal thing. So gather around, friends. Cheers. Bobby, nice to see you in the chat. Hope all is well over there. Yeah, sun's just going down, just still up a little bit. Going to be down in probably another I don't know, 15, 20 minutes, something like that. Yeah. Hey there, Tom. Nice to see you. Hope all is well with you too. So come on in. Come on in. Join the circle. Sharing a common passion for the science of astronomy. Cheers. Hey, Gilles. Nice to see you in the chat. Hope everything is okay up there as well. Yep, things are good here. Nice and quiet. Um, been trying to think about what to pull out of my back pocket if needed. I've always got stuff right there, but it's a matter of choosing, and yeah, that can be difficult. Hey, I watched the most recent um, production of Tomorrow, TMRO, where they interviewed Charles Liu, and yeah, it was kind of funny seeing Charles. He and I were actually roommates, uh, housemates for a short period of time. I think yeah, I mean, I was an undergraduate. He was a graduate, um, and or maybe even beyond that. I think he was a postdoc. I think he might have been a postdoc, and um, you know, needed a place to stay. Found us. I don't know how, and yeah, so we were roommates for a while, and that's one of the things that I noticed about Charles, uh, even back then, was that very articulate. He was able to uh, uh, say things intelligently, but in a way, you know, where most of us could sort of understand what he was talking about. So yeah, take a look at that. TM, I think the YouTube channel is TMRO. TMRO. So check check them out. Check them out. So Gilles says it's cool and rainy. Quebec national holiday. Wow. Yeah. So not too fun to have a rainy summer's day. So, yeah, well, that's where you are. So, hey, Atta, nice to see you. Yeah, okay. Yeah, Atta, they are a pretty advanced group, but it's sort of uh yeah, I mean, if what they're talking about, and I mean, I can't be certain precisely what they're talking about, but my guess is that since I think it was going to be a show on beginning astrophotography, just uh, if you want to do it, these are sort of the steps that you need to take. If you think that that is way ahead of where you are, then you're probably right. You're probably right about that. See if you want to get into that later. Um, uh, if you're new, and it sounds like you're pretty new, um, best thing in the world is to get out under the sky with some charts. With some charts. Now there are apps that you can put on your phone, right? And I think those are okay. I think those are okay. I'm not going to discount them. Um, I think that they are uh, probably pretty adequate, and it's almost like an augmented reality experience, and that's very very cool. In fact, I think I've seen some apps that actually do that. They'll look at the sky through their camera, and then on the screen, they'll draw all the constellation lines and show you where particular targets are. It's like you have a planetarium, right in your hand, and that's very very cool. So I'm not going to discount that at all. Um, the the way that I did it, and I mean, I use the resources at hand, and that's why I'm sort of not discounting any of the smartphone app things. I think those will do about the same thing that I'm going to suggest now, and that is actual physical charts. Cheers. Now, the the hardest thing to do is to translate what you see on your chart with what you see in the sky, because what you essentially have to do is you have to develop your sense of scale. It's like, okay, this whole chart, right? This whole chart that I'm looking at is a certain portion of the sky, right? And the only way, I mean, that's a thing that cannot be taught. You have to figure out how you're going to translate between what you see on paper or on your smartphone to what you're actually seeing in the actual sky with your own eyes. Um, so that's the hardest thing. That's the hardest thing. Is you have to learn how to do that. Um, and yeah, uh, as I said, Tom, I've seen a couple of those. I don't know what they're called or anything. People show me these things on their phones, and it's like, okay, well, that's cool. But yeah, I think whatever works is what I'm going to suggest more than anything else. Whatever works. So I I like to have, um, and mainly, probably just because I'm used to it, or maybe old-fashioned. But I like the old charts, right? And I've got these, and this is the entire sky. This is the entire sky, and then I've also got. Let me. I've also got that, which is more detailed. So the charts, the individual charts, cover smaller portions of the sky, and there are more stars. I think this goes down to, let's look at a chart. So yeah, the Uranometria goes down to a stellar magnitude of about 10, and then it shows a lot more non-stellar objects. And as I said, each chart is a relatively small portion of the sky. Um, I mean, several times the size of the moon. Uh, yeah, at least 10 times, if not 20 times. So, still relatively big chunks, but not incredibly huge chunks. The Sky Atlas 2000, this one, this one presents pretty big chunks of the sky. Okay, I can, for instance, chart 11. Chart 11 shows the constellation of Orion. Is it 11 or 10? I think it's 11. Yeah. So it's 11. And now I'm not going to be able to really show you this really well, but I will try to show you the constellation. There it is. So there's the constellation of Orion, but you can see that these charts are big, right? There's the Hyades up there at the top, and then Sirius down there. So you can sort of see that that's a pretty sizable chunk of the sky. But you have to be able to look at this and say, okay, here's the constellation of Orion, right? Here's the stars that sort of make up that constellation. And it's like, okay, I've got to identify where these are in the sky. So that's the easiest way, is to uh, find objects in the sky that you already recognize. That'll help you learn the sky. So that's number one, is get out under the sky and just become familiar with it. Um, you know, look at the same object over and over and over and over again. I mean, you've got to look for it, right? There's a little bit of a hunt, and then there's the find, and then there's the sort of the examination. You know, looking at it with sort of a critical eye, and seeing what kinds of details you can um, uh, identify. Even with binoculars, there are things that you can see, right? There are structures and um, patterns and all kinds of things. Yeah. So that's probably the number one thing. The the number two thing is see if you can find a local like astronomy club or society, and hook up with them, because most of these clubs have like a monthly meeting, um, where it's like the first Tuesday of the month or something like that, right? Um, and meetings are typically sort of divided into two parts. You've got the business meeting, which is just all the officers discussing uh, various operations within the club, right? And reports um, might be given, you know, whatever else. And then the other part of the meeting is usually some kind of a presentation. some kind of a either a guest from from elsewhere or a member, is doing something that they think is interesting and is mature enough to sort of show off and discuss uh, with the membership. Cheers. Um, and so, yeah, get to hear about what somebody else is doing, whatever it is, right? And then you can ask them things if you have any kinds of questions or anything, and that oftentimes leads to interesting discussions and additional thoughts. Um, and so yeah, and these these astronomy clubs also usually put on what are called star parties, and these are when some members of the club have telescopes, and they usually go to like a reasonably dark site that's also reasonably accessible. For people, so they don't have to drive for hours and hours in the middle of nowhere and all of that. They find a nice compromise dark spot. Uh, they set their scopes up, and you can go and look through their scopes. Um, Usually, there's a bunch of different kinds, so you can sort of sample them, um, see if you like any of them. Right? Like how they look, um, and then look through them, and you might uh, you know to do sort of an unbiased comparison, look at the same object with all of them. So hey, can I look at Jupiter really really quick? And they'll usually comply unless they're locked on to something and they don't want to move. But usually, we're pretty happy about showing off uh, anything in the sky. So so definitely ask, and look at the same thing through all these scopes and see which one you like the best. And you can uh, ask the owners about them and how they work and all of that. And I mean, they'll love to talk about all that kind of stuff. I mean, that's what they're doing there, is because they want to show off their equipment and show off what it can do, and give people the opportunity to expand their mind a little bit and offer a different perspective on the universe. We are relatively speaking, I think we're pretty tiny. So yeah, it's pretty amazing though. So cheers. All right, so hope everybody's doing well out there. The sun is just about to set. So what is it? 219. Oh, I've now got a blind spot right in the center where I'm looking. 219, 219, and it has just set. It's just set. So my sun has just set. The Earth has rotated such that I'm going to have to be looking through the Earth in order to see the sun. And well, it's going to start to get dark because the Earth does a pretty good job blocking that sun. It's pretty thick. It might be small, it might be a tiny little dust grain, but it does a pretty good job blocking that sunlight for half a day. Jeez, pretty amazing. Cheers. So yeah, I was trying to think about what to pull out of my pocket today to think about. Because a lot of a lot of the reason why we're all here is because we want to think astronomical thoughts, think about the universe. And there's just, I mean, my problem is not uh, coming up with things to talk about. My problem is choosing from this huge pool, um, and just narrow on like one or two things. That's hard. That's really hard because there's so many cool things going on. So I went through the newarchive.org for today, right, the 25th. The archive.org usually updates around 1 hour UTC. So for me, that's 18 hours Mountain Standard Time, so 6 p.m. Mountain Standard Time. So I'm 7 hours behind UTC always, and look through those. Didn't really see anything too interesting. Um, there was one in there that was sort of interesting, but man, I don't. Did I keep it on my screen? No, I didn't even bother to keep it on my screen. So what was that all about, though? I need to find out now. I'm gonna find out what that was because I saved the paper. Every paper I even glance at, I try to save. Oh, that's right. That's right. They were looking at the solar wind speeds using SOHO data. Do you remember the SOHO? Um, so let's go over and look at SOHO really quick. It's always fun to look at the sun. So they tell you don't look at the sun. Well, we're going to look at the sun. So SOHO has um, these two different setups such that they block the light from the sun, but um, because it's out in space, the sun is very sharp, right? There's no blurring effects, anything like that, any atmosphere. So it's nice and sharp. So they can really block it really well, and then look all around it, right? And so that's what these two are. There's sort of a wide field, which is the LASCO C3, and you can sort of see here that this white circle would be where the sun is, right? And then they've put this. I mean, what they've done, right, is they've put this mask in front of the sun, and don't really know how big it is, but what they've done is in software, they've sort of blocked out this area, and that's because putting that chronograph in there, that sun blocking thing, there's a lot of diffraction, there's a lot of optical effects that are just complete crap, right? They're completely useless. Um, uh, well, maybe not completely useless, but um, hard to deal with, right? Hard to deal with. So um, so post processing, they sort of blank this whole area out and say, okay, the useful information starts right there and then extends out. Now, a lot of these white dots that you see are background stars. Those are stars. They can do a long enough exposure, or they are doing a long enough exposure, and the camera that they're using is sensitive enough to be able to pick up some, some of the brighter background stars. I think that they can see down to, I think maybe sixth magnitude or so, which is the limiting magnitude of our eyes as well. So they can't really see incredibly faint things, but they can, that's not bad, right? So you can see that you're seeing some interesting structures here, some dark stuff and some light stuff, and they're moving all over the place. And over time, these things change. And so this paper that I was looking at was just measuring the speeds of those winds, right? You can pick up a clump of material close in and note where it is, and then you can wait a little while and identify the same clump, which probably has changed a little bit, but you can still identify its general location and determine where it is. And then you can just say, okay, well, it's moved this far in this amount of time. Therefore, its velocity is whatever it is, right? So, yeah, I think that's all they're basically doing. I think they're doing it in a sort of a sophisticated way. But anyway, that's Soho. So I think that the LASCO C2 image is essentially where this leaves off. So we can look at that. So it's a zoomed in thing. And so now that is the disk. That's the disk of the sun, and you can see that you're seeing a lot more detail now, and you're even seeing some really cool looking things up here. I'm going to get my smartphone running on my live stream. Make sure that I'm operational. Yeah, it looks like I am. Yay. So yeah, and this was as of what, 4 hours ago, 3.5 hours ago. So it's not incredibly up to date, but you know, who's complaining, right? It used to take days or weeks or months. Now it takes hours, and I'm fine with that. You can see a little bit of diffraction here. That's an optical effect. That's definitely not anything to do with the sun itself. That's an optical effect. You can see a little bit of it over here too. So then they've got these, and I think, weren't we just looking at these the other day? So maybe I won't linger too long on this. Get back to the chat here. Yeah. Soho's awesome, and SDO is also incredibly awesome. But I think my favorite is still Iris. It's an 8-inch telescope in a what's called a what is it called? Not sun-centered orbit, some kind of a sun. Anyway, it's in a polar orbit such that it's always looking at the sun, or almost always looking at the sun, and it's an 8-inch telescope, and and it's not only a telescope, but it's a spectroscope. So it's looking at your material. I think it's looking at calcium and oxygen and carbon and magnesium, a bunch of different wavelengths of ultraviolet light, and pulling out some awesome data. Anyway, so here's that. Let's just grab this, and I don't know if it's gonna play. Let's do this a different way. What did I do? Send link as. Okay, so we'll just save it like that. A minute or so. Yeah, so Soho is very, very cool. SDO is very, very cool. Iris is awesome. We didn't look at Iris the other day. I meant to. Recent observations. So what? This was taken nine, like what, 11 hours ago, something like that. So not all the data is available yet, but at least they have the info up there. Let's see when they have data available. I'm pretty sure we can actually look at any of these. They at least have the movies up, I'll bet. Hot loops, SST coordination. Let's watch this. Yeah, Gilles. Well, it's made up of a lot of different stuff, and so yeah. I think that we're going to be surprised when we realize what this what this object actually is. I'm not convinced that we have that story right. So on the left, you're seeing the actual image, and on the right, you're seeing the differences between adjacent images. So it's like image 2 minus image 1, and then image 3 minus image 2, etc. So you can see that there's some interesting things going on. There usually always is something going on. So always very, very cool to see even the smallest amount of action. You can really see it in these difference images. The contrast is just greatly enhanced when you look at the differences. So yeah, I'm always into that. So very, very cool. Let's see if we can grab one of these. Well, let's just well, gonna do that to me again. Let's do this. Oh, that'll come up pretty quick here. Looks like it's a short one. 5 seconds. There it is. Let's look at it. Might be really short. I don't know. Yeah, it's like a second. Wow. Okay. Word. Yeah, that's a little too short. Let's let's see. Let's take a look at this. These movies are usually pretty awesome. So obviously that's a sunspot area. And once this movie loads, then you can actually, even over the live stream, I think you'll be able to see it bubbling away and changing changing before your eyes. 144 frames and it's halfway done. Almost done loading. So you see that dark line in the middle there? So that's the entry slit for the spectroscope. It's behind this camera. So that's how they can do spectroscopy and imaging at the same time. And they know from the images uh, what they are looking at with the spectrum. You can see that spot is changing a little bit, right? There's some interesting motion here, this away, and there's some bubbling away here. So very cool. Almost looks like it's swirling. You see that? Looks like it's swirling around. Okay. Well, let's see. Are there any other interesting, maybe iris images? I like to get over to iris once in a while and see what's new. I like to look at the ones that are on the edge of the sun. Sometimes you see some pretty amazing prominences. So let's look for one of those really quick. Here's an edge, but it's not very exciting. Here's more edges. And all this data is available. This is FITS data. So all this raw data is easily available. You could actually, if you grabbed all of these, you could colorize each one of them. These are different wavelengths. Could be pretty interesting. Not seeing any prominences. There's a little bit there. I hate to go with the first one I find. It's usually not the best one I can find. Hmm. Well, don't want to belabor this too much. Well, there's an edge. There's an edge. Okay, let's look at this one. See how big this one is. That looks pretty big. So we'll let that load. That looks like it might take a little while, but you can see even in the picture itself, the spectral slit must be around here somewhere, because if you look at the spectrum, right, here's the edge of the sun. So yeah, that slit's got to be right there. And then, as you can see, it's seeing magnesium in the atmosphere, right, just above. See, so right here, you're seeing magnesium lines. In fact, it's hard to tell. It's probably saturated. That's why we're seeing these things. But at least out to here, right? So this high above the atmosphere, right? That high right there, you're seeing quite a bit of magnesium too. That's doubly ionized or singly ionized magnesium. I think that's part of UVC. I think, I think, and it's dangerous, right? You don't want to be looking at that stuff. But this is a spacecraft, so we can look all we want. Yeah, Atta, I I see it as a race at this point. I think I think there's an pretty equal chance right now that um, that we will survive long enough to sort of get enough of us to understand what our situation is. Um, doesn't have to be all of us; it just has to be enough. So it's a race between that and you know the crazies who have their finger on the button. So yeah, it's I see it as a race. I see it as a race. So who's going to win that race at this point? Mm, don't know yet. Don't don't know yet. And it's I don't think it's so sad if we mess that up. Um, it's I mean, yeah, I don't really think it's that terrible if we don't do that. I think I think it's probably already being done, and yeah, I mean, it would be sad to lose that race, but eh, I guess if that's how it's gonna go, that's how it's gonna go. But as I said, I think it's a 50-50 at this point. We'll see. We'll see. All right. Well, cheers. I'm going to pause and fill up my mug with some more hydrogen hydroxide. So I will be right back. And why don't we take a look at I'll let this thing load as well. Okay, I will be right back. Okay, fresh from the tap, a new mug full of hydrogen hydroxide. Ah. All right, so the sun is slowly loading here, and you can see that dark line here. But yeah, this is taking a little bit longer than what I wanted, probably because I'm loading that now. So why don't we, while we're waiting, yeah, Atta, I think that we are giving it a pretty good chance, but if we don't do it, somebody else will. So yeah, that's why I'm not too worried. It would suck, but I think that's sometimes how things go. Well, you can see that the edge of the sun there is very active. Kind of hard to see it on the live stream, but there's some structures here that are just suspended. They're just floating on top. Look at that. So that's pretty cool. All right. Well, let's. Yeah. Yeah. Well, I lean towards agreeing with what you say there, Atta. So yeah, yeah. I think it'll be fun. But you got to listen to Isaac Arthur, right? Because he's he's been doing this series that's called the Post Scarcity Society, and it's you know, this idea that okay, once you have everything that you need, what do you do? So he examines that, and I think that's an interesting question, right? All right. Well, I think while that's loading, let's let's do a quick sort of a quick um, let's do a quick object of the day, and let's really bring it back to the basics and look at one of the Messier objects. So Charles Messier was a French comet hunter back in around like 1750 or so, and he was looking for comets. Come on, random, random, random.com is not coming up. What? Huh. Wonder if random.com got. No, it's not random.com. It's random.org, isn't it? Yeah. All right. I'm being a little dense tonight. Anyway, he was a common hunter, but during his searches for comets, he came across these other things that didn't move. So he said, well, you know, when you stumble upon these in your observations, you can sort of ignore them because they aren't comets, so they're probably not all that interesting. And it turns out that these 110 objects are pretty interesting. They're, usually the brighter galaxies, open clusters, globular clusters, planetary nebulae, and gaseous nebulae. All, pretty bright. Some of them are visible to the naked eye if you have a dark enough sky, like M31, um, the Andromeda Galaxy. That is something that is visible without any aids whatsoever. Just have to know where to look. Um, yeah, there's other ones too. M41, um, uh, of course, M45, M42, M35, the Beehive cluster. Um, Trying to think of other naked eye Messier objects. M13 is a little faint. I think is a little faint to see naked eye, and a little small. I'm trying to think of other. Well, you can see sort of M46, M47 over there east of Scorpius, or east of Canis Major. Trying to think of other. Yeah, in terms of the Messier objects, I think that's about it that you can see naked eye. So there's a few. There's a few. But yeah, so let's see. Let's dive into this and see what Messier object is going to be object of the day. Drum roll, please. Oh, M31. Hmm. I I think I want a reroll on that because M31 is uh, is the Andromeda Galaxy, as I just said, and it's that's going to be a can of worms. We're never going to get out of that. Yeah, that's a hugely, hugely studied spiral galaxy, the nearest spiral galaxy to us, right? 2.2 million light years away. It's the closest spiral galaxy to us. So, but I think I'm going to pick another one. Okay, that's host prerogative because getting into 31 or 42 or 45, it's like a can of worms. It's just we're never going to get out. All right, so I'm going to do another one. Are you ready? Okay, here we go. Better drum roll, please. M18. M18, I believe, is a gaseous nebulae. I think it's a reflection nebula. I think it's either a nebula or a globular cluster. I don't remember which one it is. So let's find out. We'll go over to Simbad. Go over to Simbad. And we're going to do a basic search. And we're going to do M18. I think it's a glob. Oh, no, it's an open cluster? No. Really? Well, it shows how much I know. Oh, I thought that was a wow. Well, that's how it goes. Yeah, so it's down. So here are the celestial coordinates, the right ascension and declination. And right ascension is in hours, minutes, and seconds. So it goes from 0 to 24. And then declination is 0 degrees declination at the celestial equator, and positive 90 at the North Pole and negative 90 at the South Pole. So this is, as you can see, a declination of negative 17 degrees, 6 minutes, 6 seconds. Looks like it's coming towards us. Here's its, oh no, that's, yeah, it's coming towards us at a velocity of like 14 kilometers per second. So ain't gonna get here anytime soon, although that's really moving fast, relatively speaking. But yeah, ain't gonna get here anytime soon. Proper motion is what it appears to be moving in the sky. So this is in milli arc seconds per year. So thousandths of an arc second per year. And an arc second is 1/60th of an arc minute. And an arc minute is 1/60th of a degree. So 1 arc second is 1/3600th of a degree. And a milliarc second is a 1,000th of that. So 1 arc second, or actually 1 degree, is what, 3.6 million arc seconds, and a degree is about twice as wide as the moon. So there's 3.6 million arc seconds in a distance twice as wide as the moon. So these things are moving in, usually fractions of a milliarc second per year, because they are really far away. Really far away. So they are moving, they're moving, but very, very slowly, because they appear to be so far away. It's just like, when you're driving down the road, it's a matter of perspective, right? When you're driving down the road, the things near you, like the edge of the road, right, seems to be moving really fast. But if you look at your horizon, right, that seems to be moving very, very slowly. And actually, if you've got the moon in the field of view and you're driving along that road, it doesn't look like the moon's moving at all, right? It's staying with you. So relative to you, it's not moving at all. And that's just because of how far away it is. So these stars are, way out there, hundreds of light years at least. And that's a really long way. So yeah, they're moving. They're moving a lot, right? They're moving as fast as anything else is, right? But because they're so far away, it just appears as though they're moving very, very slowly. So there's a few other names for this cluster, M18. And I wonder if I haven't seen Uncle Bill. So Uncle Bill's probably completely passed out because he's been watching 100 channels at the same time, and so he's just worn himself out. And so, but I don't see him in the chat. So I hope Uncle Bill is okay. He probably is. He's just crazy. So actually, a lot fewer references than what I would expect from a Messier object. So distance, let's see. I'm happy to report that my calculator is still, it seems to have recovered from its temporary malfunctioning. So I'm happy to report that I can use my calculator again. I was a little bit psyched to start having to use my slide rule, but the only limitation with the slide rules is that you can't add and subtract. which usually isn't a problem. I think a lot of the simple arithmetic that I would do on this live stream is mainly multiplying and dividing, mainly. But once in a while, I think I would do some kind of subtraction. I don't know. Anyway, so the distance that they have to this is 1,296 parsecs. Now, a parsec is 3.26 light years. So that makes it 4,225 light years away. So that's pretty far for an open cluster. That's pretty far. So let's look in the vicinity here. Looks like our movie is finished. Let's look at the movie really quick. Yeah, that's just a loose collection of stars. Loose. Look at that. That's barely a cluster, you know? But that's what it is. Whoop, I keep zooming out. I don't mean to. I mean to zoom in. There we go. It's pretty. Let's look at this movie because this will probably be pretty exciting. There we go. So you can really see this thing doing what it does. So you'll see over here, this is carbon 2, this is oxygen 1, this is silicon 2, and this is magnesium 2. They're looking at it. I don't know if I can really read those wavelengths very well, but what it is, right? So this is the image over here, right? And they're scanning, right? They have this on some kind of scan platform, and there's the slit. You can barely see it, right? But it's right in the middle. And so what you're seeing with this is so this way, left and right is wavelength, and this way, up and down, is the spatial location, right? Is the location on the sun. So you're looking at a strip of the sun, but you're looking at the wavelengths. And as you can see, it's a very, very, very dynamic place. You can see how things are changing frame to frame. It's kind of hard to see on this because it disappears so fast, but I especially like the fact that we're seeing this magnesium way out in the atmosphere, way out there. I mean, you can sort of see when it comes back around, see, this is the surface of the sun. This is the atmosphere. And wow, it's really extended way out there. You see that? Let's get it. There. You see that? Isn't that cool? Let's zoom in a little bit here so you can really sort of see. Whoop. Whoop. Let's just look at the magnesium ones, huh? So is that cool or what? Let me slow it down a little bit. Let's slow it down by a factor of 4 here so we can really take a good look at how dynamic the atmosphere is. See, it's sampling these little tufts of things up here. So pretty amazing. So here's the other, here's all the spectra. As I said, what this is, oh, I can't see it. This is carbon 2, oxygen 1, silicon 2, and magnesium 2. So lots going on the sun all the time. All right. Well, there's that. Here's M18 again. So I thought I saw the Lagoon Nebula right above it. There. Is that the lagoon? I think, no, I guess it isn't. I guess it isn't. That must be something else. I know that we're in the vicinity of Sagittarius. Yeah, he's probably blacked out. Let me zoom out this far. Wow. Still not recognizing anything. Okay, so here's the Lagoon and Trifid Nebula way down here. So yeah, M18 is pretty high up then. Okay. Oh, we lost him. Oh, there he is. There he is. All right, well, let's take a quick look at the papers. So M18. Can't be a lot of stars associated with that cluster. Dozens, maybe? I don't know. Luminosity functions, study of open clusters within 1.8 thousand parsecs. Statistical fractal analysis of 25 young star clusters. Huh. Statistical fractal analysis. Well, let's see if it. Let's see if it mentions M18. Go over to the astrophysics data system. Pull up the paper. Yay. Takes a little while sometimes. So let's see. We need to go back and see if M18 has any other names, because we can definitely search for M18. Nothing there. Nothing there. Okay. So they're, if they refer to it at all, they must have been referring to maybe an NGC number. NGC 6613. There we go. So let's see what this table is here. Table 1, sample studied in the present work and information from literature. So NGC 6613, N sub T, they're not gonna make this easy. I want to say that N sub T is the number of stars in the cluster. 133 seems a little high to me, but let's see if we can figure out what N sub T actually is here. Table. Yeah, I'm not quite sure what N sub T is, except I'm hoping that it's some kind of number of something. Don't think I can. Yeah, I don't think that's going to help. No, it would have been like table 1. That's the 25 young star clusters analyzed in the present work. So what are these guys doing? Let's okay, right, fractal analysis. A large sample of young stellar groups is analyzed, aiming to investigate their clustering properties and dynamical evolution. A comparison of some statistical parameter measure for the clusters with the fractal dimension estimated for the projected clouds showed that 52% of the sample has substructures and tends to follow the theoretically expected relation between clusters and clouds. The fractal statistics was also compared to structural parameters, revealing that clusters having radial density profile show a trend of parameter S with a little line over it, increasing with mean surface stellar density. The core radius of the sample as a function of age follows a distribution similar to that observed in stellar groups of Milky Way and other galaxies. They also have dynamical age indicated by their crossing time that is similar to unbound associations. Pretty interesting, I suppose. Mass and age. Some pictures. Yeah, that sort of goes beyond where I want to go tonight, at least. What is it? 6613. So here's something. Another. Oh, I've got the hiccups now. Sorry. These are some kind of statistical numbers. Have to read it in the literature, I guess. Kind of interesting, I suppose. little above my head. All right. Well, I think I'm going to get out of here for this evening, especially since I've got to, I now have to end these hiccups. And I've got a way of doing it, but it's not going to, it's not going to work until I just totally, excuse me, totally relax. So that's how I do it. So, all right, I'm going to get out of here for now. So take care, everybody. Make sure to subscribe if you haven't already. You can hit the notifications, thumbs up, thumbs down, whichever you prefer. Make some comments. I like to hear those. Spread the word. Spread the word. We're slowly growing. Excuse me. I will be ordering my new camera tomorrow. So look for that pretty soon. And all right, I'm going to get out of here before I get completely embarrassed. So take care. Peace. Cheers. I will see you on the spin. Bye.